Hello, I'm a national math champion and I'm going to show you how to solve AMC 8 problems under 60 seconds. Watch till the end of the video if you want to learn how you can do the same. Let's get right into it. In this problem, they want us to simplify this expression, so we'll use the PEM-dash rule to simplify this. So 8 times 4 plus 2 and 8 plus 4 times 2, that would be 32 plus 2 and 8 plus 8. So that would be 34 minus 16, which gives us 18, and the answer is D. In this problem, they took a piece of paper and they folded it 4 times. So what we're going to do is, in each of the answer choices, we are going to make 4 sections, just like they folded the actual paper. Okay, like that. And then we observe how they made the cut. They made the cut with respect to the center, like that. So this is the center. That means the cut should have taken the center, and the top left part of each of the images should correspond to this. Well, that's only true in D and E, so we can cross out A, B, and C. And again, since we folded 4 times, it should be symmetrical in all 4 of the quadrants, so the answer should be E. In this problem, they are talking about something called wind chill, and what matters is the formula that they gave us. So wind chill is air temperature minus 0.7 times wind speed. So let's see what the values are that they gave us. So they told us that air temperature is 36 and wind speed is 18. So we'll just write it down, plug in the value. So 36 minus 0.7 times 18. Now we are not allowed to use a calculator in AMC 8, so we'll have to do this calculation mentally. Now 0.7 times 18, well, 18 times 7 is 126, divided by 10 gives us 12.6. So it will be 36 minus 12.6. Well, 36 minus 12 is 24, so that means this should be 23.4. Okay, so the closed answer is B. In this problem, they're just writing numbers from 1 to 49 in a spiral pattern across this grid of boxes. Well, the simplest way to do this is literally count it out. We only are concerned with the gray boxes, so let's just mark the gray boxes. So 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So this is 19, 20, 21, 22, 23, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 39, 40, 1, 2, 3, 4, 5, 6, 7. So this is 37. Now they're asking how many of these are primes. Well, 19 is a prime, 23 is a prime, 37 is a prime, but 39 is not a prime. It's divisible by 3. So only 3 of these are prime. So the answer is D. Okay, so in this problem, there are 250 trout in a lake, and a biologist catches a sample of 180 fish. And out of those 180, 30 are trout. Now they're saying, this is the important thing, that the ratio of trout to the total is the same in both sample and the lake. So let's write down those ratios. In the sample, the ratio was 30 ratio 180. Okay, and in the whole lake, well, we know there are 250 trout. The total number of fish, we don't know, so let's call that X. And these two ratios are equal, so we can write them as 30 over 180 equals 250 over X. That means X must be 250 times 6. This is 1500. So the answer is B. In this problem, they want us to place the digits 2, 0, 2, 3 in these boxes below. Now, what is the maximum value we can have? Well, let's start with the problematic part, that is the 0. Where should the 0 be? Well, the 0 cannot be in any of the bottom boxes, well, because that will make the whole expression 0. So it must be in one of the top boxes. Okay, now we have 2's and 3's. Well, one of these has to be a 2, so we can place a 2 here, and then so that it becomes a 1. And now we only have 2 options, 3 raised to power 2 or 2 raised to power 3. Ask yourself, which one is bigger? Well, 3 raised to power 2 is bigger, so 3 must be here, 2 must be here, and the answer would be 1 times 9, so the answer is C. Okay, in this problem, they've given us a rectangle, and what they want us to do is they want us to draw lines through AB and CD and see how many points on these lines lie on the rectangle. So what we can do is we can simply extend these lines. So this line is 3 to the right and 1 up. So we can keep going like that, 3 to the right, 1 up, 3 to the right, 1 up, and we see that it passes through this point. Okay, uh, the other one is 1 down and 2 to the right. So 1 down, 2 right, 1 down, 2. We can keep going like this, 1 down, 2 right, and you see it misses the rectangle. So only 1 point on these lines passes through the rectangle, and the answer is B. In this problem, there are 4 players who are playing in a tournament and they play against each other exactly twice, each of the other 3 players. Now, their win and loss record is shown here. Now, the key thing here to solve this problem is to observe that in every round, the total number of wins and losses should be equal, right? So if Lola and Lolo won, then that must mean that Tia and Tio must have lost. Again, in a round, if one person loses, the other person wins. So in this way, you can just find out that this must be 0. There are 2 1s here, so this must be 0 as well. There are 2 1s, again a 0. There are 2 zeros, that means this must be a 1. And 2 1s, so this is a 0, and then this must be a 1. So the answer is A. Okay, so in this problem, they've given us a graph. The most important thing about the graph is the label and the units. Okay, so they're saying how many seconds does she spend at an elevation of between 4 and 7 meters. So what we're going to do is we're going to clearly mark this is 4 meters and this is 7 meters. Okay, so she's between these heights for this duration right here. Okay, that's 2 seconds. And for this duration right here, that's 4 seconds. And for this duration right here, that's 2 seconds again. So the total would be 8 seconds, and the answer is B. So here we have a pi. Let's think of the pi as 1, and Harold ate 1/4. So he ate 1/4. Now, what he left behind must be 3/4. And a moose came by and ate 1/3 of what was left behind. So he ate 1/3 of 3/4. That will give us 1/4. So the moose also ate 1/4 of the pie. And if you combine these, we get half. So that means these two combined ate half. Now half of the pie is left. Porcupine ate 1/3 of that. So that means porcupine ate 1/6 of the pie. Now, how much is left behind? It is just half minus 1/6. Take a common denominator, so 6 minus 2/12, which is 1/3. So the answer is D. Okay, in this problem, they want us to find the speed in miles per hour. Speed is distance traveled over time taken. The distance has to be in miles, which they have given us. We can approximate that as 300 million miles. But the time is given in months. Well, we have to convert that into hours first. So 6.5 months times 30 days times 24 hours. Well, let's do some calculations. 6.5 times 20 would be 130, plus half of 65 is 30, so that would be 130 plus 30 is 160, times 3 would be 480, times 10 would be 4,800. Well, we can approximate that as 5,000. So distance traveled over time taken would be this. These 3 zeros will cancel out with these 3 zeros, and 5 times 6 is 30. So the answer in this problem, they want us to find out the ratio of the area of the shaded region to the big circle. Well, the area of the big circle is, well, the radius is 3, so it's 9 pi. The area of this shaded circle is going to be 2 squared pi, so that's 4 pi. The area of this circle is pi. This is also pi. This is half squared pi, which is 0.25 pi. And so the total shaded area would be 4 pi minus pi minus pi plus 0.75 pi over 9 pi, which ends up being 4 minus 2 plus 0.75. That is 2.75 over 9. We can multiply both of them by 4 to get an even number. So that would be 11 over 36. So the answer is B. So in this problem, we have a racetrack. Let's say the total length of the racetrack is X. It has 7 water stations. So these 7 water stations will divide it into 8 equal parts. That means each of these lengths is x over 8. Now it has 2 repair stations. That means they will divide the racetrack into 3 equal parts. Each of these lengths would be x over 3. Now they said the third water station, which would be 3x over 8 away from the starting line, is 2 after the first repair station, which is x over 3. Now we move all the x's to one side and take a common denominator, which would be 24. So we'll get 9x minus 8x over 24 equals 2. That means x equals 48, and the answer is D. In this problem, we have 5-cent coins, 10-cent coins, and 25-cent coins. There are 20 of each of them, so this will make a total of $1, this will make $2, and this will make a total of $5. All of these 60 coins combined will make a total of $8. Now, we want to use as many coins as possible to make a total of 710. Now, we should remove the coins with the maximum value first. So let's see how many coins can we remove of 25 cents. So we can remove a maximum of 3 25-cent coins. That will take the total to 725. Then we can remove a maximum of 1 10-cent coin. That will make it 715, and 1 5-cent coin. That will make it 710. So remove a total of 5 coins from 60. So the answer is E. In this problem, we have a person who takes a detour to go to school. They want us to find out what should be the speed of the person on this part of the journey so that he gets to school at the same time. It usually takes him 10 minutes. Half of the journey is the same, so that means this is 5 minutes. So this green part of the journey should also take 5 minutes. How long is that? That is 7 blocks. Each block is 0.05 miles. That means the distance is 0.35 miles. So speed is distance over time. So we get the speed to be 0.07 miles per minute. Now they want the answer to be in miles per hour, so we multiply that by 60 minutes, and that gives us 4.2 miles per hour. So the answer is B. In this problem, they want us to count the number of P's, Q's, and R's written on this 20 by 20 table in this pattern. Along the diagonal, we have a single kind of letter. So let me write them down, P, Q, R. So we have 1, 2, 3, 18, 19, 20. Now the longest diagonal would have 20 letters. Beyond that, we will start decreasing again. So 19, 18, 4, 3, 2, 1. So now the first thing we observe is that the number of P's and R's are the same since they are symmetrical. Now to count the number of P's, we can see that 19 and a 1 makes 20, 16 and a 4 makes it 20, 13 and a 7 makes it 20, so that's a total of 60. Then 18 and a 3 makes it 21, 15 and a 6 makes it 21, 12 and a 9 makes it 21, so that's a total of 63. And this 10 in total, that's 133. Since P and R are both 133, the answer is C. Now in this problem, they want us to fold this net to make this shape, and they have told us that the front face is Q. Now let's use our spatial reasoning to find out what comes at the question mark. So underneath Q is 6, so that means this must be 6. To the right of 6 is 7, so that means this must be 7. And then to the left is 5, so that means this must be 5. And we keep folding, that means this must be 4. Then we fold up, so that means this must be 3. Now if you fold it down, 1 would be on the left side, but since we are folding up, 1 would be on the right side. That means this question mark is 1, so the answer is A. In this problem, we have a grasshopper sitting on a long line of lily pads. The grasshopper can jump 5 lily pads to the right or 3 lily pads to the left, and it's starting from 0 and has to get to lily pad number 2023. Now, to get there, we will make jumps of 5, so we want to find out the nearest multiple of 5. So we can keep adding 3's, and we find out that the nearest multiple is 2035. So we can make jumps of 5 and get to 2035 in 407 jumps. And from there, we can backtrack 1, 2, 3, 4 jumps, and we will get to 2023 in a total of 411 jumps. So the answer is D. In this problem, they want us to find out the ratio of this area to the area of the inner triangle. These are all equilateral triangles. An equilateral triangle with a side length of x, this would be x over 2. This is x over 2 square root of 3. So the area of this equilateral triangle is given by a half x times x over 2 square root of 3, which gives us x squared square root of 3 over 4. The inner triangle would be 2 squared over 3 squared x squared square root of 3 over 4, since the side length is 2/3 x. So this would give us 4 over 9 x squared square root of 3 over 4. So the difference between them would be 5/9 x squared square root of 3 over 4, and the area of the trapezoid would be 1/3 of that. Now we want to compare that with the area of the inner triangle. So that would be 4/9 x squared square root of 3 over 4. This whole thing cancels out with that. This 9 cancels out with that. So the answer would be 5 over 12. So the answer is C. In this problem, they're inserting two numbers into this list so that the median does not change. So the median is 8. That means they're inserting one number in the first half and the other number in the second half. The maximum number we can add to the first half is 7. We can't add 8 because that would change the mod. The mod still has to be 3. So the first number is 7. Now the range previously is 25, 28 minus 3. The range doubles, so that means the range now is 50. So for the range to be 50, the number we need to add here is 53. So the two numbers we add are 7 and 53. Their sum is 60, so the answer is D. In this problem, we have numbers from 1 to 9, and they want us to divide that into 3 equal groups with the same sum. Total sum of numbers from 1 to 9 is 45. That means each of these groups must have a sum of 15. Now 8 and 9 must be in separate groups. So let's say 9 goes here, 8 goes here. Now with 9 we need the other two numbers to add up to 6. We can do that in two ways, using 9, 4 and 2, or 9, 5 and 1. In the first case, if we use 9, 4 and 2, then with 8 we must use 6 and 1 to make a total of 15. And then the rest of the three numbers must go here. So that's the first way. Now if we use 9, 5 and 1, then with 8 we must have 4 and 3 to make a total of 15. And then the rest of the three numbers would go here, and these are the only two possible ways to do this, so the answer is C. In this problem, we have a sequence in which every term is a product of the two terms before it. The best way to do this kind of problem is to actually write down the sequence. Let's say the first two terms are A and B, the third term would be AB, the fourth term would be AB squared, and the fifth term would be A squared B cubed, and sixth term would be A cubed B to the 5. That is supposed to be 4,000. Now let's do the prime factorization of 4,000. So 4,000 is 4 times 1,000, which is 2 times 2, and then the 1,000 is 2 times 2 times 2, and 5 times 5 times 5. So this gives 5 cubed and 2 to the 5. If we compare that to our sixth term, that shows us that A is equal to 5, so the answer is D. In this problem, each of these boxes can be any of these 4 tiles, and they want us to find the probability that this diamond will be within that pattern. Probability is given by successful number of possibilities over total number of possibilities. The total would be 4 raised to power 9, since each of these 9 boxes can have 4 possible patterns. Now let's say that the diamond was here, then that is fixed. But the other 5 boxes can be anything. So there are 4 raised to power 5 possible ways to do that. Since the diamond can be in 4 places in total, so we can multiply this final answer by 4. So the answer is 4 raised to power 6 over 4 raised to power 9, which is 1 over 4 raised to power 3, which is 1 over 64, so the answer is C. In this problem, these lines are parallel. That means these triangles are similar. Since the gray areas are equal, let's call them X, and let's call the area of the bigger triangle A. Now using ratios, 11 over H squared would be equal to area of the top triangle, which is A minus X, over total area, which is A. For the other triangle, it would be H minus 5 over H squared, equals, so the top triangle is X over the total area, which is A. Now we can simplify this as 1 minus X over H, which tells us that this 11 over H squared is equal to 1 minus H minus 5 over H squared. Now if you simplify that, this cancels out, and we get 10H equals 121 plus 25, which gives us H equals 14.6. So the answer is A. In this problem, we have numbers from A1 to A15, and they're equally spaced. That means that there are 14 spaces between them. If each space is X, that means A1 plus 14X must be A15. Rearranging that gives us A15 minus A1 equals 14X. The greatest multiple of 14 less than 250 is 238. Since 238 is 14 times 17, that means each gap is 17. Now, how do we make 238? If we take 215 as 241, then A must be 3. And if the gap is 17, then A2 must be 20. Since that's barely within the range, that means A1 is indeed 3. So A14 must be 3 plus 13 times 17, which is 224. The sum of digits is 8, so the answer is A. Wondering how I did that? Well, I've been training for math competitions since I was 8. And during all that time, I learned the best problem-solving strategies and techniques from the best mathematicians in the world. I used those strategies to become a national maths champion and represented my country in International Mathematical Olympiad 3 times. Since then, I've been teaching my students those exact same strategies to ace their math competitions. And I can teach you how to do the same. For you guys, I've put together a comprehensive AMC 8 preparation course. This course is divided into 4 weeks, and each week we'll go over number theory, geometry, algebra, and combinatorics. You can use those videos to learn all the techniques that you need for those topics. Then I'll assign you practice worksheets where you will get to apply those techniques to real AMC 8 problems. Then at the end of the week, we'll have a live problem solving session, but most importantly, you will have my unparalleled support. I will be there to make sure that you are able to perform to the best of your ability on the AMC 8 exam. The course is starting soon, so use the link in the description to go to the website and reserve your spot now. I'll only be accepting a few students in this session, so hurry up before the spots run out. I'll see you there.